right, so let me start the presentation. Outlook detection. Please, can you all see my screen?
Yes, we can see. You're good.
Fantastic. All right. So this is a tutorial on outlier detection and treatment. So an outlier is simply a data point in a data set that is distant from the overall distribution. Okay, in other words, it's far away from all other observations. That's in very simple terms what outlier is. And I'm sure most of you know what it is. Now, how do we detect outliers, right? We can do so by using visualization tools, and one of them is box plot. Okay, when you plot a box plot, usually the data is supposed to be between the lower whisker and then the upper whisker, right? So between this and this is supposed to be the range of the data. Anything beyond the upper whisker or below the lower whisker is an outlier. So in this case, we can see 3 outliers. Okay, so then we know that this particular column in our data set has this number of outliers. Okay, so this is with monthly average hours. Okay, so we know that monthly average hours has an outlier. Then when you come to the satisfaction level 2, we can see that, oh, this column also has some outliers. And the same applies to last evaluation. Okay, so this one we're just trying to plot. So the y in this case, or on the y-axis, we want the monthly average hours, and then on the x-axis we want the salary, right? So it tells us that for those who earn low salary, their monthly average hours, they have this number of outliers, and for medium is this number. For high, they don't have any outliers. Okay, so you can also use a scatter plot to also visualize whether there are outliers in your data set or not. And when we do that for satisfaction and then last evaluation, we see that there are this number of outliers. Okay, now how do we treat it? So there are a number of ways of treating outliers. In this tutorial, I covered only one of them. For the rest of it, you have to go and do your own research on how to treat outliers. So one way of treating it is using what we call the interquartile range method, right? So what you do is that you calculate the first quarter, or the first quartile and the third quartile, right? So the first quartile is simply, so you take the column of interest, dot quantile, and then into bracket. So the first quartile is 0.25, and the third one is 0.75. Okay. Then once you've calculated the first the Q1 and the Q3, then you calculate the IQR, which is the interquartile range, which is Q3 minus Q1. Okay. So now that you have Q1, Q3, and then IQR, then now we calculate the lower whisker and the upper whisker. The lower whisker is simply Q minus 1.5 times the IQR. Okay, and then the upper whisker is Q3 plus 1.5 times IQR. Right? So once you've calculated the lower whisker and the upper whisker, then we now come to plot it. So essentially what we are doing, because we've already visualized, you know, where the outlier is, we realize that the outlier was above the upper whisker. Okay, that's for the last evaluation. So let's get back to the last evaluation. Yes, so this is the last evaluation column. We realized that the outliers were above the upper whisker. So if we want to take away the outliers, well, all we have to do is that we have to plot the values below the lower whisker, right? So what we have to do is that we now set the emp at, which is the name of the data set, is equal to emp at, then into brackets, the emp at last evaluation, which is all the values in this last evaluation, less than the upper whisker, right? The outliers are above the upper whisker. So we want to plot the values below the upper whisker. So once we do this and we plot it, we realize that we've taken out the outlier. Right, so this is a very simple way of treating outliers by taking them out. There are more advanced way of doing them, but I mean, for our level, just knowing the simple one is enough. Okay, so that's it. There is also the z-score method, right? But I'll leave you to go and do more research on it. I've left a reference here. You can visit the link and then read more on the z-score method. But then in this tutorial, we're just doing the interquartile range method. And for this week challenge, I think in the third task, you have to treat some outliers, right? There are some, that is if only there is some, or there's any, you have to treat it. And you can use the interquartile range method to do that. Okay, so that is the end of the tutorial. Like I said, it's very short. So if you guys have any question, you can please feel free to ask me.
I have a question, but it's not on this. I don't know if you can just handle it, if you know.
Oh, feel free, ask.
Yes. So we are required to, as part of task one, we are required to segment the users according to the desert classes, like the top five desert classes.
Yes.
And I've checked and I've not seen a very straightforward way of doing that. I don't know if you know somewhere you can point out. If anyone amongst us knows it, just put it in comment.
So what you can do is you can sort that particular column, right?
Nothing like that.
Once you sort that column, the first decile becomes the first 10. The second decile becomes the next 10. The third one becomes the next 10 in that order.
Yes.
Do you get it?
So, but after you sort them, let's say the first desert, like it's not only one particular thing that is there. So how are you
Come
segmenting it
again.
out? How are you segmenting it? You can sort it and then you see that okay, these are the members of the first desert or something like
Mhm.
that. How are you checking those particular rows out?
Please, can you come again with your question? I didn't get that.
So after you have applied the desert method, then you sort them kind of, and you see the group of users that are in maybe the first desert, users that are
Mhm.
the second desert. So how do you take them out of the entire data frame? I want to segment the data frame into okay, this
Oh,
person
okay.
is the owner
So
of it.
one way you could do it is to just handle it separately. So once you so for example, if let's say you're finding the first decile of, let's say, users who used Netflix, for example, right? You just separate it. You just select that particular column. You sort it. So you select it with the users, right? And then once you sort it, then now you select the first 10, and that first 10 becomes your first decile, and then the second 10 becomes your first decile. Do you get it?
And all that. So let's
Hello,
go to
can you hear me?
Yeah, Olusola.
Hello.
Yes, Olusola.
Oh, Emmanuel was asking that can we replace the outlier with the mean of the data set?
Um, yeah, it's possible. It's possible. You can do
Please, can
that.
you show?
Come again.
Can you show us?
I mean, it
Please.
wouldn't change. It wouldn't change much. It wouldn't change. It wouldn't change the data set in much. I mean, the change is insignificant. So even if you do it that way, it's okay. Like I said, the main purpose of the challenge is not for you to get the right figures or what is the right figure and so on and so forth. It's more about, you know, your ability to derive insight, right, from the data set that you have. That is the main purpose, and your ability to communicate that. Okay, so it's not really about getting the correct figure and so on and so forth, but it's more about approach and then how you're able to communicate, your ability to derive insights from the data set. Okay, so I mean, if you decide to take out the outlier, it's fine. If you decide to replace it with the mean, it's also fine. I don't think it will change much. Maybe in certain scenarios, it would make a much difference, but in this scenario, it wouldn't make much difference. So anyhow you do it is fine. Yes, Biniam.
Thank you. So in the interquartile range method, did we
Yes.
just calculate the upper and the lower whiskers and drop every value that's not between these two?
Right. So if your outliers, so for example, if your outliers are above the upper whisker, then you plot only values below. Uh, you plot values from the upper whisker and below. Did you get it?
Yeah. So we just excluded the outside, right?
That's right. Yes, you just exclude them. That's all.
Okay.
Yeah. Patrick, you said observe that even after treating the missing values based on the volume of outliers in the column, choosing between median or mean, the distribution of most features do not seem well skewed, even after log normalizing it. What do you have to say about this? Which columns specifically are you talking about, Patrick? Hello, Patrick. What columns are you talking about?
Patrick, are you there?
The XDR sessions. So the XDR session, right, or the bearer ID is the unique identifier for each session. Okay, so that one you can't do anything. So if there's a missing value in the bearer ID column, all you have to do is to drop that column because it's an ID. It's not a number. It's an ID. So if you impute it or if you do anything to it, it's going to it's not advisable to impute it because it's an ID. You get it. So you can't impute it or find a mean or mode or whatsoever.
Hello.
So the session duration.
Hello.
Yeah, so for the session duration, that one,
What about the MSSN number?
yeah, so that one too is an identifier. It identifies a customer. So that one, if there is a missing value in that column, you can just drop the column.
Okay.
Yeah. So for the session duration, Patrick, so for the session duration, for the session duration, you can, so that one is it's a figure, right? Or it's a float or an integer. So that one you can replace the outliers. You can replace the missing values with the mean. So that one is fine.
Hi,
So-
Sebastian.
Yes, but
How about I found out that there was something labeled undefined in the handset type. Do we drop them as well, or we leave it as it is?
or you can just leave it as it.
Please, can I answer him?
Then come again.
What I did was I replaced that undefined with unknown number, that np.nan.
Okay.
Okay,
It's
that's
just
yeah.
it's supposed to be a type of let's say a mobile phone, but then the name is not known. Kind of.
The name is not, yeah, exactly. The name is not. So you can just leave it as undefined in the data set. Even when you plot it, it would come as undefined. And when you're explaining it, you explain that, it represents, some mobile sets, some mobile handset, but just that the name is not known, right? Because I realized that when I also plotted it, I also realized that it was huge, right?
Yeah.
So it appeared in, I think, the first 5 or so. So I think that it makes a difference. So you can just leave it as it is, and then it can appear in your graph as well.
Okay.
Yeah, so that's fine.
Someone was telling me that I should change the data type of some column. Should I do that?
What columns?
For example, MS duration, and also this. Let me check it, please. Sorry. Okay. For example, now Netflix BL byte, and also total UL byte.
Okay, so those ones, they are in bytes. Okay, so you can convert them to megabytes, right? Because the figures are huge, so you can convert them to megabytes or to gigabytes. I mean, however you want, but just indicate, that if it's megabyte, indicate it. If it's gigabyte, indicate it. Is that fine?
Okay.
Yeah.
Yes, yes.
Yeah, Biniam.
So my question is, what do the whiskers signify, and why do some whiskers have long widths and some are somewhat narrow? Why is that?
Come again.
My question is, what do the whiskers signify? What's their purpose? And why are some whiskers longer than the others?
Right. So the whisker, um, so in this case, so when you look at this, right, this side, can you see my screen?
Yeah,
Yes, we
yeah,
can.
I can
Right.
see it.
So this area where the mouse is, right, represents the Q1, and this area represents the Q3, and this is the upper whisker, this is the lower whisker. Now, if this side is bigger than this side, it only means that there are a lot more. So it means that a lot more values between, or there are a lot more values between the lower whisker and then the Q1. Remember, the Q1 is 0.25. Okay, so it means that the numbers below the 25th percentile are more than the numbers between. So let me take that again. The numbers below the 25th percentile are more than the numbers above the 75th percentile. That is what it means. Do you get it? Hello?
Yeah, yeah, yes, I got it. I got it. Thanks.
Exactly. So that is why you can have that difference in length.
Okay, okay, that was clear. Thank you.
Yeah, sure. Any more question? Yeah, Ada, you have a question?
I'm repeating the question that Patrick is talking about.
Mhm.
Between main, median, and mode, which is the best to use to impute the outliers in your data if you prefer not dropping them?
Um. So the median, and so if there's outliers in the data set, it's advisable to use the median to replace. If you want to replace the outliers, it's advisable to use the median, because when you use the mean, it may not be accurate, right? Because the outliers can change the mean, I mean, altogether. So if you want to replace the outliers, it's advisable to use the median. Yeah. Nahom, you have a question?
Yes, thank you. So my question is on task 2.1,
Mm-hmm.
the third subtask of 2.1. Compute the minimum, maximum, average, and total non-normalized metric for each cluster.
That's right.
Problem is, we already have it normalized. So what does the term mean, non-normalized total and average?
Okay, fantastic. Good question. Right. So when you calculate your k-means, right, it returns what we call labels. It returns a label, and you
Yeah.
can use the property. I think it's something. It's labels actually. That's the property. So you can use it to get all the labels. So what you do is append the labels to the original data set, which is the one you normalized.
Yeah.
right? Not the normalized one, no. The one you normalized on. Do you understand what I'm saying?
Oh, I see. The original one.
The original
So
one. So append the labels to the original data set,
I see.
and then you can then aggregate based on the cluster. So it will give you 0, 1, 2. The labels that you got from the k-means is 0, 1, 2, since you did 3 clusters, right? And then so once you append it to the original data set, then you can aggregate based on the clusters.
So so what are the minimum, maximum, average, and total non-normalized metrics? I mean, I appended it on the original one. I get that part, but appending it on the original part on the original data set is clear for me. What
Mhm.
I did not get is what are we supposed to calculate or compute by what does it mean by minimum, maximum, average, and total
Right.
of the non-normalized metrics? I mean, the metrics mean the columns. Is that it?
Yeah, the metrics, I'm coming. The metrics are supposed to be, let me check that. So the metrics are the session frequency, the duration, and then the
Oh,
total traffic. Do you get that?
oh, yeah, yeah, yeah. Sorry, my bad. Yeah.
Right. So those are the metrics. So my guess
Yeah,
is that your original data set has this 3 metrics, right?
yeah, that's true. Yeah,
Great. So
yeah,
once
that,
after you've appended the labels to that original data set, what you have to do is you can use
yeah.
the group by. Okay. So you group by clusters and then you aggregate. So when you're aggregating, you can aggregate. So you can then aggregate on the mean, the max, the average, and then the sum. So the total will, in this case will be sum. You can use the sum to aggregate the total. So what you're trying to do is that what is the minimum? So for example, if you're finding minimum, so in each of the clusters, what are the minimum or what is the minimum duration in cluster 1? What's the minimum duration in cluster 2? What's the minimum duration in cluster 3? When you come to the mean or the average, what is the average duration in cluster 1, average duration in cluster 2, average duration in cluster 3, and so on and so forth. That is what you're trying to find.
Yeah,
Do you get
thank you. Perfectly
uh,
clear now. Yeah.
yeah. Any more question? All right. So if there's no more question, please feel free. Anytime you have one, just put it on Slack, and then I'll be happy to assist. Until then, it's a bye for now. Bye bye, everybody.
Hello.